Welcome, everyone, to TechDaily.ai. I am your host, David.
And I'm Sophia.
And before we get into things today, you can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you are interested, visit TechDaily.ai to get started today.
Yeah, it is. It's really a great way to get your message out there.
Absolutely. So, when we talk about the cloud or artificial intelligence, there is this, tendency to imagine something totally invisible, right?
Over.
Like it's just something floating quietly in the ether. We type a prompt into our screens, and the answer just seemingly materializes out of thin air.
Right. The language we use, the cloud, the ether, virtual networks, it does a remarkable job of completely masking the sheer heavy physical reality of what is actually happening behind your screen.
Exactly. But if you actually pull back that curtain, the cloud is heavy. It is made of millions of tons of concrete. It is constructed from massive steel structures, crisscrossed by thousands of miles of thick fiber optic cables. And it requires literal rivers of electricity to function. So today, our mission is unpacking a massive, landscape-altering $5 billion artificial intelligence cloud venture that was just formalized between Google and Blackstone.
And I think it's important to note this isn't just, another software update or some algorithmic breakthrough. This is really about laying down the heavy physical tracks for the future of the entire global economy.
The stakes here are entirely physical. While everyone online is endlessly debating AI software and, analyzing the nuances, different conversational bots, the real existential war is happening in the infrastructure and the silicon chips that power it all.
Exactly.
So our goal for you today is to understand how this specific partnership aims to challenge Nvidia's absolute dominance in the AI chip market, and ultimately what this means for the future of the AI economy as a whole. Okay, let's unpack this. Let's look at the actual anatomy of this $5 billion partnership.
Right, so Blackstone is coming in heavy here. They are making an initial equity investment of $5 billion into this new venture. And the whole business model here is what they are calling compute as a service.
Compute as a service. That's a big shift from how things usually work, right?
It's massive. Compute as a service is basically the economic engine of this entire deal, and it drastically changes how a company operates. Because historically, if you wanted to build a massive software platform, you had to endure immense capital expenditures, or CapEx.
Like physically buying the gear.
Exactly. You had to physically buy thousands of servers, find a facility to put them in, wire them all up, maintain them. It was a massive barrier to entry. But compute as a service shifts that to an operating expense, or OpEx.
So it's more like a subscription.
Yeah, precisely. Instead of buying the incredibly expensive hardware up front, developers and enterprises simply rent the raw computing power over the internet. It transforms incredibly complex, hyper-expensive hardware clusters into, well, just a predictable monthly utility bill.
It essentially democratizes the compute power for everyone else.
Mm-hmm.
But to make that utility model function at a global scale, this venture is merging two wildly different superpowers.
Right.
Because on one side, you have Blackstone bringing their massive data center capacity, the physical site operations, and all the networking architecture.
And then on the other side, Google is bringing their custom silicon, specifically their tensor processing units, or TPUs, along with their whole enterprise software layer.
And they are moving incredibly aggressively. The timeline states they expect to bring the first 500 megawatts of capacity online by 2027.
Which is just, to put 500 megawatts into perspective, we aren't talking about upgrading a server room here.
No, not at all.
That is grid-scale power.
Yeah.
It is roughly the energy equivalent required to run a medium-sized city, and that is just for this initial phase.
Wow.
Yeah. Securing that kind of power requires negotiating with regional utility monopolies, building dedicated electrical substations, and, engineering industrial cooling systems capable of keeping millions of chips from literally melting.
Which perfectly explains their choice of leadership for this thing. They have placed Benjamin Traynor Sloss as the CEO of this new venture.
Right.
Sloss is a Google veteran with over 2 decades of experience specifically building and operating Google's global physical infrastructure. He's not an AI researcher, he's not a software developer, he is a logistics and infrastructure heavyweight.
What's fascinating here is what that appointment reveals about the bottleneck of the AI boom.
Oh, how so?
Well, you would assume a trillion-dollar titan like Google has, all the resources it could ever need to scale. But the sheer physical constraints of acquiring land, Navigating zoning laws, securing grid interconnects, and pouring concrete are so severe that even Google needs external capital and world-class commercial real estate expertise to move fast enough.
That makes total sense.
Yeah, I mean, money alone doesn't clear a 5-year wait list for a utility interconnect, right?
Blackstone brings the physical real estate execution that Google desperately needs to deploy its technology. Let me try to visualize this because it feels fundamentally different from like typical tech partnerships. Think of it like building a nuclear power plant.
Okay.
Blackstone isn't just buying the land. They are constructing the concrete containment units, engineering the massive cooling towers, and managing the high-voltage grid connections. Google, in this scenario, is simply bringing the highly enriched uranium, their TPUs.
Right.
The uranium is entirely useless without the reactor to harness it, and the reactor is an empty shell without the fuel.
That is a highly accurate mechanical analogy. Blackstone builds the reactor, Google supplies the specialized fuel. And it really highlights why neither company could easily do this on their own at this speed.
But knowing that Google has this specialized fuel, it raises the logistical pivot. Like, what is so special about these specific chips that warrants a $5 billion reactor? Because without the silicon, as you said, this is just a giant air-conditioned warehouse.
Yeah.
So let's examine Google's hardware offensive. Google recently unveiled its 8th-generation TPUs, and they made a deliberate architectural split.
Yes, they did.
They introduced the TPU-8i, which is their first dedicated inference chip. Then they introduced the TPU-8T, which is optimized entirely for massive model training.
And that split is honestly the most critical technological detail in the entire venture. We all know the industry bottleneck over the last few years has been the brute force compute power required for frontier model training.
Right, which is basically Nvidia's fortress.
Exactly. Training requires ingesting the entire internet over months, demanding incredibly high bandwidth connections between tens of thousands of chips. But the TPU-8i signals a strategic pivot toward inference at scale.
And inference is, just to clarify, that's what happens when the model is actually live, right?
Yes, exactly. When millions of users are pinging the API, generating text, or analyzing data in real time, that's inference.
Right. I want to look closely at the training side first, though, because Amin Vahadat, Google's chief technologist for AI infrastructure, made a staggering claim at the launch. He stated the TPU-8T is built to reduce the frontier model development cycle from months to weeks.
Yeah, that is huge.
If you look at the compounding advantage of that, it alters the fundamental physics of corporate innovation. I mean, if an AI lab can iterate, fail, adjust, and train a new frontier model in 3 weeks instead of 3 months, their R&D cycle just went into hyperdrive.
Oh, absolutely. And Alphabet is backing this up with almost incomprehensible sums of money. They recently raised their capital expenditure plans for 2026 to between $180 billion and $190 billion.
Wow.
We are talking about capital expenditures that rival the GDP of entire nations, deployed primarily to secure this physical infrastructure and silicon.
That is just hard to wrap your head around.
It is. And they aren't just building this in the hope that customers will show up eventually. Google has proactively secured multi-billion-dollar agreements with absolute heavyweights like Anthropic and Meta to provide them with TPU compute.
Locking them in early.
Exactly. They are methodically locking in an ecosystem of top-tier AI developers who are structurally reliant on Google's silicon architecture.
But wait, I have to challenge this narrative a bit.
Yeah.
We hear constantly that Nvidia effectively owns the AI industry. They have an immense competitive moat, primarily because of CUDA, their proprietary software platform that almost all AI developers are trained on.
Right. CUDA is everywhere.
So are Google's custom TPUs actually capable of breaking that stronghold just by throwing $180 billion at data centers? Or is this just an incredibly expensive brute force game of catch-up? Because here's where it gets really interesting. You can't usually break a developer software moat just by building bigger warehouses.
That is a very fair point. You are hitting on the exact multi-billion-dollar tension in the market right now. And if we connect this to the bigger picture, the answer lies in that shift from training to inference that we talked about.
Okay, lay it out for me.
You are absolutely right that NVIDIA's CUDA dominates the training phase where developers are actively writing custom kernels. But as AI moves from the research lab into daily automated utility, integrated into millions of enterprise workflows, raw training power becomes secondary. Efficiency becomes the dominant economic metric.
Right, because when you are running inference millions of times a second in a live production environment, The electricity bill and the thermal management become your biggest liabilities.
Precisely. Google Cloud CEO Thomas Kurian emphasized this exact point. He stated that TPUs are optimized specifically for efficiency and performance in the AI era.
Performance per watt, basically.
Yes. When an enterprise is running a model 24 hours a day, performance per watt is the only metric that dictates profit margins. If Google's TPU-8i can execute those live inference requests utilizing 20% less power or generating significantly less heat than an Nvidia GPU, it radically alters the operating economics for the software company.
Oh, I see.
Yeah, so Google didn't necessarily have to dethrone Nvidia in the developer training lab to capture a massive, highly lucrative share of the long-term inference market. They're competing on operational expenditure, not just raw computing power.
That reframes the strategy completely. It's like the difference between building a massive fuel-thirsty tractor for heavy lifting versus engineering a highly aerodynamic, efficient hybrid engine for a fleet of millions of delivery vehicles.
That's a great way to put it.
You need the tractor to build the roads, but the daily delivery roads are where the long-term volume and profit reside. Now, having explored Google's silicon strategy, we have to look at the financial juggernaut making this physical expansion possible.
Right, Blackstone.
Yeah, why is a private equity firm stepping into the middle of a silicon architecture war? Because for context, Blackstone is the largest global provider of data centers, currently holding over $1.3 trillion in assets under management.
$1 trillion in assets fundamentally changes your risk profile and how you view emerging technologies. Private equity generally abhors unpredictable risk. They favor stable, predictable cash flows.
Which AI startups definitely are not right now.
Exactly. In the AI gold rush, betting on which specific software algorithm or foundational model will win 5 years from now is incredibly risky. But betting that whoever wins will require massive amounts of power, cooling, and floor space, that is a near certainty.
They are executing the ultimate picks and shovels strategy, but on a macroeconomic scale. And they're organizing around this thesis aggressively. They recently created a specific unit called Blackstone N1, or BXN1, which is entirely dedicated to their portfolio of investments in the AI ecosystem and high-growth technology.
Yeah.
John Gray, Blackstone's president and COO, framed it as a generational opportunity to invest capital at scale building AI infrastructure, citing the unprecedented demand for compute.
But the strategy goes deeper than just deploying capital. Jasvinder Khaira, the head of Blackstone N1, made a highly revealing observation about the limits of their own resources.
What did he say?
He said, capital alone doesn't build category-defining platforms. The right partner, the right structure, and the conviction to underwrite singular opportunities do. Google's TPUs, a decade in the making and foundational to the AI economy, are exactly the kind of platform BXN1 was built to back.
Wow, that is a stunning admission from an executive whose entire industry is built on the power of capital. He is openly acknowledging that money cannot buy time.
Right.
You can have $1.3 trillion in assets, but you cannot instantly purchase a decade of deep silicon research, architectural testing, and compiler optimization.
No, you really can't.
Google has been quietly iterating on these TPUs for 10 years. Blackstone has the cash, they control the land, and they have the utility relationships, but they absolutely need Google's 10-year head start in chip R&D to make those data centers competitive.
It is a symbiotic necessity, and if you look closely at Blackstone's recent moves, they are busy weaving a heavily fortified web of these alliances. Yeah, earlier this month, Blackstone partnered with Anthropic and Goldman Sachs to form a new $1.5 billion AI services company specifically aimed at deploying the Claude model to mid-sized businesses.
Wait, look at how those names overlap. Google is partnering with Blackstone on the hardware infrastructure. Blackstone is partnering with Anthropic on the software deployment. But Google also has a multi-billion-dollar cloud agreement with Anthropic.
Yes, exactly.
They aren't just forming isolated partnerships, they are weaving an interlocking ecosystem of capital, infrastructure, and frontier models.
That interlocking ecosystem is the core strategy here. It is a highly coordinated effort by multiple trillion-dollar entities to hedge their bets and construct a viable, fully integrated alternative to the Nvidia monopoly. They are ensuring that the capital, the hardware, and the software are all pulling in the exact same direction.
So what does this all mean for the listener? Blackstone isn't just acting like a passive bankroll here. Are they essentially positioning themselves as the ultimate physical landlord of the AI economy?
That is the exact reality of this venture. If you own the data centers and the power contracts, you own the toll roads of the 21st century.
Right.
By weaving themselves into the fabric of Google's hardware rollout and Anthropic's software deployment, Blackstone ensures that no matter which AI model ultimately wins the software war, they are the ones collecting the rent on the physical space and the electricity required to run it.
Boy, brilliant.
They are securing the foundational, undisruptible layer of the entire technological shift.
It is a masterstroke of real estate and technological synergy. So let's concisely recap the architecture of what we've explored today. We started by examining a massive $5 billion handshake between Google and Blackstone to construct a utility-like compute-as-a-service venture. We dug into the sheer physical reality of scaling 500-megawatt data centers, requiring grid-level power negotiations and the operational oversight of a 20-year Google infrastructure veteran. From there, we zoomed into the microscopic architecture of Google's 8th-generation TPUs, distinguishing between the brute force of model training and the highly efficient, margin-driven daily grind of inference.
Right.
And finally, we zoomed all the way out to Blackstone's trillion-dollar pivot, realizing that private equity is methodically positioning itself as the permanent toll booth operator of the AI revolution.
This raises an important question to consider. We spent a lot of time discussing the compute-as-a-service model and how it shifts costs from CapEx to OpEx.
Sure.
If AI computing power becomes heavily centralized into these massive utility-like mega ventures run by giants like Google and Blackstone, what actually happens to the next generation of garage startups?
Oh.
Does this massive, hyper-efficient infrastructure make it fundamentally cheaper and easier for anyone to just rent AI power, effectively democratizing innovation across the board? Or does it mean the literal keys to the future will exclusively be held by the corporate landlords who own the data centers, the power grids, and the custom silicon?
That is the ultimate tension at the heart of this technological shift. Are we building a public, accessible superhighway, or a private toll road where only the deepest pockets can afford the rent? Thank you for joining us for this conversation. Keep asking these exact kinds of questions and never stop staying curious. Because as we have seen today, the cloud isn't floating invisibly in the ether. It is anchored in millions of tons of concrete, powered by custom silicon and aggressively guarded by a few massive gatekeepers holding the keys to the physical world.